That good? Okay, I guess two things. Everybody has one of these? I have been given this to share with you. It's a handout from the MLC, and
oh, that looks awesome.
It has the unit circle. If you look on the back side of it, it has a bunch of properties and everything else. And no, you cannot have this for the test. It also has the days in which the problem sessions for Math 135 are on. And I guess it came at a more or less opportune time, considering Wednesday is your test. There you go.
Nope. No other time.
Thank you.
Do you have any more of those outlines?
Yes.
Can I get one?
Yes. Who else needs one?
I need one of those.
Okay, so questions.
Yes.
One question or question one?
Number one.
Okay.
All it came to the problem where all I had was -3 minus h.
Hold on. You're talking about A, B, or C?
A.
A. Okay.
Yeah, I got all the way in the problem where I have -3 minus h. I thought we plugged in 0 for h.
That's only when you have the derivative. If you remember section 1.1, which is what we're having here, we only deal with difference quotients. And the whole point of it was a preparation for when you get to the derivatives where you actually have to take the limit. Here, the only thing you have to do is just work out the algebra as far as the difference quotient is concerned. Now, I should point out that 3 minus h is not the right answer.
Yeah, I'm in -2.
That's still not the right answer. There should be some h's. Again, you don't put 0 for h.
Don't you pull out the H and then it cancels? I pulled out the H out of the top.
Okay? But you should still have an h, don't you? Because when you put in 3 plus h in for x squared, you'll end up with h squared.
Yeah.
Do I need to do that?
Oh, really?
Okay, 1a. F of x is equal to 4 plus 3x minus x squared. And so we're looking at f of 3 plus h minus f of 3 divided by h. And by the way, I should probably point out, since I heard two people now saying something about x's, there's no x's anywhere here. So we have 4 plus 3 times 3 plus h minus 3 plus h quantity squared minus, and now what's f of 3? 4 4 plus 9 minus 9.
Yeah.
So ends up being 4. Divided by h. Right? 4 minus 4 is 0. So I have 9 plus 3h minus 9 minus 6h minus h squared divided by h. 9 minus 9 is 0. So I end up with minus 3h minus h squared over h. So I end up with minus 3 minus h.
You can do C.
Sure. Does this make sense? I skipped a step here. I didn't actually factor out the h first. Right? If you factor out the h, you end up with minus 3 minus h, quantity multiplied by h, divided by h. The h is cancelled and you're left with this. Okay. 1c says f of x is equal to the square root of x plus 4. So we're looking at f of x minus f of 0.
No, C, not B.
Oh, that's b. Oh, never mind. Sorry about that. Okay. So f of x equals 1 over x. And we're looking at f of x minus f of a divided by x minus a. So we're looking at, bless you, 1 over x minus 1 over a divided by x minus a. So far so good? Okay, so now, what do we have to do here? Multiply and divide by the least common denominator, which is x times a. And so what are we left with? A minus x divided by x times a times a. Divided by x minus a, right? Times x minus a. Yes.
I thought it'd be 1 over all of that. Why is it?
Well, what happens when you multiply 1 over x times x minus a times x a? Why would it be 1? I have 1 over x times a. That will give me a. And I have 1 over a times a. That will give me x. Right? And what next? Factor out a negative. So observe that if you factor out a negative on the top, you end up with x minus a divided by xa times x minus a, which equals minus 1 over xa.
Where's the negative from? Why do you do that?
Do you always factor out the
Because you have to cancel them out.
Oh, okay.
we try to cancel out something from the top to the bottom?
Yes, remember, that's basically what we're trying to do. We're trying to find the limits right in the end. And so you always have to be able to factor out and simplify things. Yes?
Can you also talk about
B?
because I got 1 over square root of x.
1 over the square root of x?
Yeah,
That's not the answer.
I know. That's why it's
Okay, so 1b says f of x equals the square root of x plus 4. And we're looking at f of x minus f of 0 divided by x. And so what we're looking at is we're looking at the square root of x plus 4 minus 2 divided by x. Too fast? Keep going? Okay. And now, what do we do here? Multiply by the conjugate, right? So multiply and divide by the square root of x plus 4 plus 2, square root of x plus 4 plus 2. So we're left with x plus 4 minus 4 divided by x times the square root of x plus 4 plus 2. So I have x over x times the square root of x plus 4 plus 2. The x is crossed out and I'm left with 1 over the square root of x plus 4 plus 2. Okay? What else? Yes?
I'm getting confused on how to determine whether a function is odd or even.
Okay. What is the definition? When is a function odd?
Negative of x.
F of negative x is equal to negative f of x. And f is even if f of negative x is equal to f of x. Right? So, do I need to do any of them?
Yeah, I understand the definition. I just don't know what.
How to apply it? Well, which one would you like me to do? A, B, or C?
About B.
Neither.
Okay. So B. F of x is equal to x over x plus 1. So f of minus x is going to be minus x divided by minus x plus 1, which is equal to minus x over minus x plus 1, but this is not equal to minus f of x, nor is it equal to f of x. Right?
Minus f of x would just be multiplied with the whole thing.
Yes, because minus f of x is minus x over x plus 2, over x plus 1, and then f of x is just x over x plus 1. Yes. See? Everybody sees? See? Is that the Spanish for yes?
Yes.
Okay. Okay. F of x equals cosine of x plus sine of x squared. So f of minus x is going to be cosine of minus x plus sine of minus x quantity squared. So it's equal to cosine of minus x plus sine of x squared. Right? Now what happens with cosine of minus x? Cosine of x is an even function, which means cosine of minus x is equal to cosine of x. And so as a consequence, cosine is an even function, sine is an odd function, but because I have x squared, it ends up actually being that this is also even. So it turns out that we come back with f of x. Remember, cosine is an even function. Well, okay. Cosine and secant are even, right? Since secant is just 1 over cosine. And then sine, tangent, and cotangent, what I guess in cosecant, are all odd. Everybody remembers this? You do now, right? Yes.
So you keep the squared on the sine negative because you know that it makes no difference Because you took the minus negative out.
Well, minus x quantity squared is just x squared.
Okay.
Yes.
Okay, 5. I know we've been over it a bunch of times. I just want to make sure.
I got a quick question on the function thing. What happens? I forgot the rule. Like if you add an even and an odd function together.
Neither.
Neither.
Think about the previous problem we just looked at. X is an odd function, 1 is an even function. You add them up and you end up with nothing. When you multiply them, however, it's different. Remember, when you multiply them or divide them, it's the exact same properties. It would be minus times plus. Okay. Number 5?
Yeah.
Which one? Both?
Yeah.
How did you do the first one?
So anybody attempted to graph it? No? So I finally managed to achieve my goal. So we have f of x equals x to the fourth minus 5x squared plus 7 if x is less than 1. And it is equal to the square root of x squared plus 2x plus 6 as long as x is bigger than or equal to 1. Right? Okay, so now if x is less than 1, what can we say about f of x? Well, it's going to be x to the fourth minus 5x squared plus 7, which is a polynomial, continuous everywhere. Right? As a consequence, f is continuous on the interval minus infinity up to 1. Right? Yes?
Yes.
Okay. If x is bigger than 1, what happens? What's f of x? The square root of x squared plus 2x plus 6. It's a rational function. Continuous on its domain. What is its domain? What is its domain? All reals. Why all reals? Because x squared plus 2x plus 6 ends up being strictly positive. Why is it always strictly positive? Well, because the discriminant is less than 0. Do you remember what the discriminant is? The quadratic formula, what does that say?
Square across the
Minus b plus or minus the square root of b squared minus 4ac divided by 2a. b squared minus 4ac is called the discriminant. What happens if the discriminant is less than 0? If the discriminant is less than 0, you can't have square root of negative numbers, and so as a consequence, your solutions are all complex, which means your graph is never going to cross the x-axis. Because it never crosses the x-axis means it's either always positive or always negative. Anybody remembers any of this?
I never learned that.
Oh, you did. Oh, yeah.
I'm the only one that didn't take calculus.
This is not calculus.
Not calculus.
This is actually intermediate algebra.
Well, I learned that, but not.
This is actually intermediate algebra.
So we're talking 9th grade, 4 years ago.
So the idea was the following. If b squared minus 4ac is less than 0, you have no solutions. If b squared minus 4ac is equal to 0, you have one solution. And if b squared minus 4ac is bigger than 0, you have two distinct solutions.
So what is the b squared minus 4ac? What is that in our equation that we're working with? That's just whatever's in there.
It's 4 minus 24, so it's negative 20. So it's 2 squared minus 4 times 6 times 1. So it ends up being negative 20, which is less than 0. I rigged it on purpose, so it's continuous everywhere. Does this make any sense?
Yes.
Do you understand why this is the case? Again, we talked about quadratic functions quite a lot in this class because they happen many times. The idea about quadratic functions is they either look like a u or they look like an n, right? That's the graph. How do we determine if it's a u or an n? The first term, if it's either positive or negative, right? So, if it's a u, and the discriminant is less than 0, means the graph doesn't cross the x-axis, means it'll look like this. Notice it's above the x-axis, which makes it always positive. Yes?
Yes.
Wonderful. So now if we come back to what we're talking about, we came up with a conclusion that the square root of x squared plus 2x plus 6 is continuous everywhere. Right? Since its domain was all the real numbers. Yes?
I just looked at it and I thought, well, no matter what number I put in for x, it's going to all be positive.
Why?
Because if I plug in a negative 2 for x, I mean negative 2x squared plus 2 times negative 2, and then I have the plus 6, it's just going to be positive. I can plug in negative 100, and I'm still going to get a positive number for that square root.
How do you know?
Because I just plug in, I can plug in negative 3 million, and I'll still get
Okay.
a positive number.
So as it turns out, that is the case. However, that's not the place for calculus. You don't plug in random numbers, because what happens if 5 of them work but a 6th doesn't? And so you actually have to show why that's the case, and that's where the why comes into play. Again, this comes back to what I've been talking about the entire semester. For your test, if you just write the answer without actually explaining how you got the answer, you're basically going to get barely any points. Because I want to make sure you actually understand how you got the answer, and not the fact that just, it happened, it's lucky. As in, for example, one of the most popular answers as far as when I ask for limits is the answers are always either 0 or infinity. If you don't know, you usually just say either 0 or infinity, and chances are sometimes you actually get lucky and you hit on it. But it doesn't necessarily mean that you know why. You're just basically guessing. And so I would like to actually see why things are happening. And you don't have to be, as I said before, it doesn't have to be written in a more in a very fancy way or elegant or whatever. Just explain in your own words, if not, why exactly you think that's the case. Does that make sense? Okay. So coming back to our problem over here, this means that f is continuous on the interval 1 to plus infinity. Right? Yes?
Yes.
Okay. So what do we have left to do? And remember, this is what I was, when we looked at the quiz, this is what I was trying to warn you. The fact that I have an equality sign here, I can actually extend and say that this is continuous on one bracket to positive infinity. Okay? But it doesn't matter. If I show that it's continuous on minus infinity to 1, and I show that it's continuous from 1 to plus infinity, it doesn't mean I show that it's continuous everywhere. Is everybody understanding this? Remember, the example would be that. Okay? So what are we left to do? we need to look at x is equal to 1, right? So we need to look at the limit as x goes to 1 minus of f of x, which is going to be the limit as x goes to 1 minus of x to the 4th minus 5x squared plus 7, which ends up being 1 minus 5 plus 7, so it is equal to 3. And we need to look at x, the limit as x goes to 1 plus of f of x, which is the limit x goes to 1 plus of the square root of x squared plus 2x plus 6, which is the square root of 1 plus 2 plus 6, which is the square root of 9, which ends up being equal to 3. Both of them being equal to each other means what? It means that the limit as x goes to 1 of f of x is equal to 3, right? Which happens to be f of 1, right? Because f of 1 is the square root of 1 squared plus 2 plus 6, which is the square root of 9, which is equal to 3. Does that make sense? Now, didn't I actually write the entire solution for this problem? I'm pretty sure I did, right? Oh, so you just wanted to see if I can actually reproduce it?
Yeah.
Did I do a good job? Yes.
So in order to show that f is continuous on negative infinity to positive infinity, you need to show that f is continuous on each piece's domain.
Yes. And the fact that they're joining.
Oh, and they're joined. Okay.
Which there's two parts to call. First, we show that polynomials are continuous or rationals are continuous from their domain, and then we do that.
Yes. But you have to make sure that, their domains are actually the correct domains.
Yeah.
Because if I would actually give you the second branch of it being x squared minus 2x or plus 2x minus 6, then it turns out this is not going to be continuous everywhere. Why? Because this is actually going to have two distinct roots, which means the domain is actually going to be from minus infinity to the first root, from the second root to the positive infinity. And so you're actually going to be missing a piece. And that's why we spend the time talking about these. Now, in light of this particular problem, do you see why I was trying to be nice to you and actually give you like a x squared and a square root of x? Instead of, x to the 4th and the square root of x squared and all that fun stuff?
You gonna be that nice on the exam?
I won't be that nice on the exam. Because I know, I can guarantee some of you are going to have this brilliant idea that you're going to try and graph things instead of actually trying to show things. And so, no. Okay, what else? Yes? Number 9. Okay. Oh, well, I guess there's no page. So number 9. Here, to be creative, number 9 on page 2. Okay, we're supposed to find the equation of the normal line to the parabola y equals x squared minus 5x plus 4, and the normal line is parallel to the line x minus 3y is equal to 5. Right? So what should we do? Well, whenever we hear the words normal line or tangent line, what would be the first immediate thing we want to do? Find the derivative. So dy over dx is equal to 2x minus 5. Right? What is the next step? So what is our issue here? We need to find a normal line, the equation of the normal line, that's parallel to this particular line, right? Yes?
Since you know it's parallel to the line, find the slope of the line.
Because it's parallel to this line, it'll have the same slope, right? So we're actually going to have the slope. What are we actually missing? We're missing the actual point, right? How can we get to the actual point? So from here, y is equal to 1/3 x plus 5/3 minus 5/3, right? And so the slope is going to be 1/3, right? So what should we do? Well, normally, how do you get to the slope? How do you get to the slope of the tangent line? You take the derivative. What's the next step? Plug in your point in for x, right? And that would give you the slope, right? I already have the slope. So the question is, for what value of x I get 1/3? Which means 2x minus 5 has to equal 1/3. Right? Which means 2x has to equal 16/3, which means x has to equal 8/3. Right? So what next? We found the value of x. We need the value of y? Hey. Wrong. Why is it wrong? I just realized the big mistake. What is the slope for? What is the slope of? What is the slope of?
The normal line.
The normal line. What is this derivative giving us? Slope of the tangent line. So what you actually need to solve is 2x minus 5 has to equal -3. Which means x, or 2x, is equal to 2, which means x is equal to 1. Does this make sense? Yes? So what next? We need to find the corresponding value of y. So that's just going to be 1 minus 5 plus 4, which ends up being 0. So what is the equation of the normal line? Y minus 0 is equal to 1/3 times x minus 1. Does this make sense? Yeah? Did I get the same answer? Wonderful.
Could you do 6, I guess G, one of those experts that
6 G.
Yeah, G.
It is 2. I guess you have the answer, so that doesn't really help you. Bless you. Okay, we have the limit as x goes to infinity. of 4x to the 4th plus 5 divided by x squared minus 2 times 2x squared minus 1. So you want this the long way or you want this the short way?
The way that makes.
X goes to infinity. This is a ratio of polynomials, right? Remember what I was telling you about rational functions and limits going to infinity. And as I said, this only works when you're going to infinity and when you're dealing with rational functions. Because it's a rational function, I want to look at the largest power. The numerator has x to the 4th as the largest power. The denominator has x to the 4th as the largest power. And so the limit is just going to be the ratio of the coefficients, which means it's going to be 4 divided by 2, which equals 2. Does that make sense?
Yes.
Is that all the work we have to show on the exam?
As long as you basically say it in words what I more or less just said, then yes. Basically, if you say, they have the equal powers, then you look at the ratio of coefficients, then yes. Yes.
Could you do 6H?
Did I not do that problem?
Yeah.
I think I did it. The square root of 9x squared plus x minus 3x. I think I did this problem when we were talking about limits a couple of weeks ago. But what should we do? Well, if you put in infinity for x, notice that the square root is going to be infinity, right? Minus infinity. And so the idea is we're at an impasse. Why? Well, because we have infinity minus infinity. I briefly mentioned at some point that that's called a indefinite form. But more importantly, we don't know which one of the two infinities is going to win, or if they're actually both going to positive infinity, kind of like the same rate. In which case, you actually end up with a number, which is actually this particular situation. You end up with, what is it, a sixth or minus a sixth? One of the two. I don't remember. A sixth. So what can we do? Multiply by a horizontal bar. Multiply by square root of 9x squared plus x plus 3x divided by the square root of 9x squared plus x plus 3x. And so this becomes the limit as x goes to infinity of 9x squared plus x minus 9x squared divided by the square root of 9x squared plus x plus 3x. Right? The 9x squares cancel out, and then what do we do now? I have x divided by the absolute value of x times the square root of 9 plus 1 over x plus 3x. Right? Yes? And now what happens with the absolute value? We're going to positive infinity, so that goes away. So I just have x divided by x times the square root of 9 plus 1 over x plus 3. I kind of skipped a step here and there. Yes?
Okay, you know how we have the square root of 9x squared plus x?
Mm-hmm.
We factor in absolute value of x.
We're factoring out x squared.
Oh.
Well, how else can you take it out of the absolute value, the square root? That's one of the steps I skipped.
The absolute value of x squared is x.
The square root of x squared is by definition the absolute value of x, since you can't have negative numbers inside square roots.
What if it wasn't squared? We still take out the absolute value of x.
square root. What's the square root of 3? Is it an actual number? Integer? How about the square root of 4? What is it? 2? Why is it 2? Because 2 squared equals 4. So it has to be squared to be able to take it out. Right? Does that make sense? Okay. Alright, so now the x is crossed out. We put in infinity for x. 1 over x is going to be 0, so we end up with 1 over the square root of 9 plus 3, so we end up with 1 over 6. Does this make sense?
So if it was like a 9x plus x, like not squared, could you still take out the x or not? Okay.
If this would have been, first of all, I should probably point out, if this would have been the square root of 9x plus 1, let's say, right? So let's say this would have been x over the square root of 9x plus 1 plus 3x, right? Okay, well, I can have x over the absolute value of x times the square root of 9 over x plus 1 over x squared plus 3x. Does this make sense?
Yes.
And now when you go through the actual factoring out, so as soon as the absolute values drop out, you factor out the x, you can cancel it, and when you put in 0 or infinity for x, this whole thing is going to be 0, and you're only going to be left with a 3. Yes?
Okay, towards the last step, we plug in infinity for x. Why does 1 over x turn to 0, but 3x just turns into 3?
Yeah.
There's no more x. I factor out an x.
Oh.
I only have 3 here.
Underneath it.
Well, he was talking about the 3x here.
Yeah. Well, so when you factor out the absolute value of x, take out the x.
No, that's just for the square root.
Okay.
Then the next step was actually factored out x in the whole denominator. Notice there is a 3x there, there is not a 3x here. Now, is everybody understanding why 1 over x goes to 0 as x goes to infinity? Yeah? Okay.
Is that actually any kind of any number over x as x goes to infinity 0?
Yes, because the number can just come outside of the limit. Now, based on previous quiz experiences, I should probably point out the only times you actually ever factor out an x is if you go to infinity. If you don't go to infinity, there is absolutely no reason to look at a fraction of 1 over x. Because it's not going to go to 0, it'll just go to whatever number is when you put in x for it. So if x goes to 4, it'll just be 1/4. Okay? So there's really no point in actually factoring it out. Is that making sense? Yes?
I know like 1 over x, when you're going to infinity, turns into 0. What if you're going towards negative?
Both cases, so both infinity and negative infinity, that's going to be, when I said infinity, I basically meant both of them.
Yeah.
I meant, going basically to the far ends of the universe.
Okay, I wasn't sure.
To boldly go when no one has gone before, yeah. Is this making sense?
Yeah.
Yeah.
Okay. What else?
So then that answer right there would be 1/3.
For this one?
Yeah.
Yes, for this one it would be 1/3, if you take the limit to infinity. Again, one of the things that I was telling you about calculus in general is, I would like you to do two things. When you get your test, first of all, spend a second or two to look at the problem and realize what you're actually asked to do, rather than actually just jumping in directly. I showed you a couple of times in which, things might look a lot worse, but if you actually just do a little bit of a simplification, like an algebra, things may, look a lot easier, right? I gave you like an example of a derivative, right, last time. And the other thing I would like you to do is, I don't expect you to stare at the problem and the answer, just pop out. Just basically go ahead and we'll go through the motions of what you've learned how to do. You don't have to just look at the problem and say, I wonder what the answer is. Okay? Just work it out and chances are you'll actually get the answer. Does that make sense? Okay. What else?
Well, any of them. I get it, I just want to see if I'm doing it right. Let's do a
12?
Yeah.
Okay. By the way, do you have any questions from the homework, considering it's due on Wednesday?
I do.
Okay.
I've been waiting.
Okay. All right. So let me do 12a, and I guess I can answer the questions from the homework, considering that's basically 12, right? All you're doing is finding derivatives in the homework, right? So, okay. So 12a says f of x equals the square root of x plus 1 over the cube root of x to the fourth. Now remember the two derivatives I talked about last time. The derivative of square root of x is 1 over 2 times the square root of x, and the derivative of 1 over x is minus 1 over x squared, right? These are the two derivatives that I'm usually not going to spend any time solving anymore, just because, as I said, they'll show up so many times. It might not become apparent right now where they actually show up, but you'll see they do as soon as we get to the chain rule. Okay, so then f of x is the square root of x plus x to minus 4/3, right? So when I take the derivative now, I'll end up with 1 over 2 times the square root of x minus 4/3 x to negative 7/3. And so it'll be 1 over 2 times the square root of x minus 4 over 3 times the cubed root of x to the 7. Make sense?
Is that it? No more simplifying?
That's it.
Okay.
Yes.
What in the language of the question would indicate that we need to show more than just the power rule?
In what sense? It says simplify as much as possible.
I know, but like,
So the only reason why I'm going through the extra step is because I told you I want you to write with positive exponents. I want you to get used to writing with positive exponents. And so that's basically the only thing that I'm going from here to here. I'm dealing with this x to the negative 7/3, writing it with positive exponents. Okay? So that would basically be the only extra thing I more or less ask of you. Otherwise, if you look at a rational function, so when you actually have to apply the quotient rule, then as we've seen last time, you should simplify things because chances are they're going to be much simpler than your whole mess. Yes?
Would you rather us write it when we bring the negative 7/3 back to the denominator? Would you rather us write it like that, or can we keep it as just 4 over 3x to the 7 positive?
You can write it as x to the 7/3 if you want. Chances are you're probably better off writing it as a square root, but it doesn't really matter that much at this point. The only reason why I said it's probably going to be better if you write it as a square root is because, again, the question would be what's 8 to 2/3? Sorry? So the idea is this is the form you would really like because it ends up just being equal to 4. Right, if you go through the motions. But it doesn't have to be at this point. The fact that at least you notice that it's in the denominator should help you out, at least, like kind of like visually interpreting what you're looking at. Like, for domains or things of that nature. Okay, what else?
Yeah.
Why? What is your problem with tangent?
Okay, I'm bad at trick, but I was thinking if there was no 2 in front of the cosine, I see that cosine of x, like at the top is pi over 2, and horizontal tangent would be at pi over 2.
Cosine of pi over 2 is 0.
Oh, never mind. It'd be 1. It'd be 0 or 2 pi.
You also have an x there.
Yeah, I know, and that's where I'm confused.
Well, we did this problem in class. The only difference is I switched it, instead of having sine, I wrote it with cosine. So this is exactly what I'm trying to tell you, as far as you don't have to look at the problem and hope that the answer comes out. Go through the motions of what you've been taught. How do you deal with tangents? It's a question. Tangent lines. Take the derivative. So if you look at f prime of x, it will be 1 minus 2 times sine of x. Right? And now the next question would be, when are tangents horizontal? When the derivative is equal to 0. Right? So what you're looking for is, you're looking for sine of x being equal to 1/2. And as you can see, it has nothing to do with 0 or 2 pi, even though that's where cosine actually is horizontal. Yes? Because of this minus, you have minus 2 sine of x equals minus 1. Divide by negative 2 basically, so you'll end up with 1/2. And then to answer the end of this, this is basically what the solution is in the book, in the notes I gave you, right? You just look at when the sine is 1/2. Yes?
So basically for a problem like that, the first thing we should do is find the derivative and then set equal to 0. That's pretty much
Yes,
that.
and that's why I said, again, don't look at the problem and try to get the answer just by looking at it. You should focus on, that's why I said, when you read the problem, spend a second or two to realize what you're actually supposed to do. So when you read the problem and it says, for what values of f does the graph has a horizontal tangent, that should come out immediately and say, oh, tangent line, okay, clearly I need to look at the derivative. That's basically what I meant about reading the problem and going with what you're actually being taught. As in, like, what are the steps associated with whatever, the problem is asking. Yes?
Will it ask you for a vertical tangent? I can't remember if we did that.
We haven't done vertical tangents. And the only times we're actually going to talk about vertical tangents is when we look at improper integration. Implicit differentiation is what I wanted to say. So, like for instance, if you look at a circle, because vertical tangents means your slope is infinity, and it's really hard to actually detect when would the slope be infinity. Moreover, if it's a function, it'll never have vertical aspect. Well, I guess it could, but it's very seldom. I guess would be cube root of x. That would be one example. But the way you actually deal with that is we'll see. You'll actually make the denominator 0 if it has a denominator. We'll talk about that. I guess in about a week or so, a week and a half. Okay. Homework?
Yeah. We just did an example of it, but number 26, it was find the equation of the tangent and the equation of the normal. I got to the tangent, but for some reason I'm having a hard time figuring out what the normal would be.
Well, if you have the tangent and the normal, the only difference from the tangent to the normal is, instead of 12, like you have, is minus 1 over 12.
Okay.
Remember, the normal goes through the exact same point. The only difference is its slope is the inverse of the reciprocal.
Okay.
And so that's actually the only difference that you have to look for. So if your problem is asking you for the tangent line and the normal line, It's not really that much more work versus, if it actually only asks you for the tangent line. The only difference is you just have to write the equation again with a different slope. Does that make sense? Yeah, because it goes through the same point. So the only thing that changes is the actual slope. Okay, that was easy. What else?
Number 14.
What page or what section?
2-3.
2-3. 14?
Yeah, I think I just got it.
Ha! Apparently, I managed to put that in your review. Yeah, that's part B. And then F is again 16. That's not cool. And I probably shouldn't have told you.
I got that answer.
So never mind?
Well, I just got a -7 on the top, but I see where, I see where I got it.
Okay.
Appreciate it.
What else?
Number 22.
Number 22. This is one of the reasons why sometimes I really don't like the way Stewart makes things. We have y equals sine of theta divided by 2 plus c divided by theta. Now if you look at the original question, it says 1 through 24 problems, it says differentiate the function, right? Well, what's my variable? Is it c or is it theta? Because if it's c, it's a lot easier. And so this is one of the things why I don't necessarily sometimes like the way he writes things, because if you actually would have said f of theta, then at least I know theta is my variable, which I know that's exactly what he meant, because obviously if c is my variable, then it's kind of pointless to do this. So what is the derivative of sine of theta? Cosine of theta? So what is f prime of theta? Well, because sine of theta is divided by 2, that's just a constant, right? So it's just cosine of theta divided by 2. Does that make sense? Yes?
Yes.
I kind of did it on purpose in your review as well. What is the derivative of x squared divided by 2? And the answer is that 2 in the denominator doesn't play a role when you take the derivative because it's again a constant. It is the same thing as saying the derivative of 1/2 times x squared, which will just be 1/2 times 2x. Does this make sense? And so coming back here, now what's the derivative of c over theta? Negative c over theta squared. Why? Because the derivative of 1 over x is negative 1 over x squared, right? C is a constant. It doesn't play any role, right? I mean, if you really want to be creative and bust out the quotient rule, I guess you can. Just keep in mind that the derivative of c is just 0 because it's a constant. Yes? So the idea is that c over theta is just c times 1 over theta. And c is a constant. Does that make sense? Okay. What else?
On number 36, for the tangent, you take the derivative and set equal to 0. But it doesn't have definite factors, so we use the quadratic equation.
Yes. Yeah, it actually will have square roots. right? Because the discriminant is, what is it, 36 minus 12, so it's 24.
Yeah.
So that's just going to be 2 squared of 6. So, I guess, what would be the answer? 3 plus or minus square root of 6?
I got negative 1 plus 2 squared root of 6. I don't know.
You can't do that.
I can't?
It's not a product.
Oh, okay.
Okay, what else? Sure. I'm very surprised nobody asked me number 8 on the review.
Really? That's easy.
Why is it easy?
Just separate them and figure it out. Oh, on the review, I'm sorry.
Yeah, I was about to ask.
What's up?
I was about to ask that, but we don't know.
Yeah, I'm sure you were. U times A cosine of U plus B cotangent of U. So we're supposed to find the derivative of y. So what is our variable? Well, on the same token as before, it only makes sense that the variable is actually u, right? Otherwise, it would be rather, kind of lame. So what's the derivative? What should we observe? That it's a product of two functions. U is a function of u, and whatever the parenthesis is a function of u. So that means we need to apply the product rule. So it'll be A cosine of u plus B cotangent of u plus u times, and what's the derivative of the parenthesis? Negative A sine of u minus negative B cosecant squared of u. Right? Yeah? Remember, we spent the time talking about derivatives of trigonometric functions last time, and which ones have negatives, which ones don't, and how they're connected to each other, right? Remember that? Okay. What else? So how would you do number 10 on the review? Oh, number 8 on the review. Well, I guess I gave you the answer, so it doesn't help anymore. Well, what's the idea? The key idea about it is the fact that it asks if that particular derivative exists, right? And so the only way we can actually deal with that is if we actually look at the limit, right? Notice that the function is defined to be x times sine of 1 over x whenever x is not 0, right? Which means the function is defined everywhere, right? And so it'll have a derivative everywhere because you can take the derivative everywhere except at 0, right? And so the only question is what happens at 0, okay? The one thing I should point out is the fact that sine of 1 over 0 doesn't make sense will not be a sufficient reason to say that the derivative doesn't exist. Okay? If I am to actually give you a function of this nature, f of x equals x squared times sine of 1 over x when x is not 0, and 0 when x is 0, would f prime of 0 exist? the limit as x goes to 0 of f of, do I want to do that? Should I do, let's go through the actual definition.
We're doing
Do we-
what, if problem, or are we doing it?
This is 8 prime. It's x squared instead of x. 8 had x times sine of 1 over x. And as you can see based on the solutions, that doesn't have a derivative at 0. As it turns out, this will. Even though it might not look like that.
What?
It has a derivative, f prime of 0 exists. The limit as h goes to 0 of f of 0 plus h minus f of 0 divided by h is equal to f of 0 plus h is just f of h, so that will just be the limit as h goes to 0 of h squared times sine of 1 over h minus f of 0, but f of 0 is defined to be 0, so that doesn't show up anymore, all divided by h, right? Which equals the limit as h goes to 0 of h times sine of 1 over h. Right? And what is this limit? It's 0. Why is it 0? There's a particular theorem you need to apply here to come up with the conclusion that it's 0. Would you know what that theorem is? There's only one theorem we actually talked about as far as limits are concerned. And you all laughed when I actually told you the name of it. The squeeze theorem. Why? Well, minus 1 is less than or equal to sine of 1 over h is less than or equal to 1. Right? Which means h, or minus h, is less than or equal to h times sine of 1 over h is less than or equal to h. H goes to, minus h goes to 0, h goes to 0, so it'll force the middle term to go to 0 as well. Key idea is sine is bounded between minus 1 and 1, and h goes to 0, so it doesn't matter what value it gets. The point is, it'll end up being 0, right? The only time that wouldn't work is if actually you have 0 times infinity. That's when you would actually be kind of in a problem. Does that make sense? 0 multiplied by anything is 0, except if you're talking about infinity, since infinity is just a concept. Okay, what else? Anything else? So my point is, you have to be a little careful about things, because you might have said the derivative doesn't exist because sine of 1 over 0 doesn't make sense, okay? But that's not really the reason why it doesn't exist. The limit doesn't exist when you actually go through the motions of it, okay? I can come up with a bunch of other functions that will still have a derivative, even though they look kind of weird, okay? All right, let's see. Anything else? Yes.
Did you do 13 already on the review? Did we go over that?
Nope.
Alright. Did we do 13C?
13C, okay? We have y equals x plus 2 divided by the square root of x. And we're looking at the point 4 and 3. So, what do we need to do? Exactly. It says find the equation of the tangent line. What you should get from that is we need to look at dy over dx. Right? So now what is the derivative? Looks like a ratio of two functions. And so what we need to apply, it's called the quotient rule, right? So we have 1 times the square root of x minus 1 over 2 times the square root of x times x plus 2, all divided by x. Right? Okay. What next? Well, we would like to make this a little nicer. So we will have 2x minus the quantity x plus 2 divided by 2x times the square root of x. Too fast? Well, least common denominator. The least common denominator is 2 times the square root of x. When you multiply the first term by 2 times the square root of x, it ends up being 2 times the square root of x squared, which is just 2x. Right? So I have 2x minus the quantity x plus 2 divided by 2 times the square root of x times x. Yeah? Okay? And so this just becomes dy over dx will be just x minus 2, bless you, divided by 2x times the square root of x. Dy over dx at x equals to 4 will be 2 over 8 times the square root of 4. Right? So it's 1/8. So my problem would be y minus 3 equals 1/8 times x minus 4. Does that make sense? Okay. So then we'll stop here.